In this video, we're going to be demonstrating CanBUS connectivity between two Flexs SCADA PLCs and showing just how easy it is to set up CanBUS communication on your Q5. Let's get started by connecting network and power to each of our devices. And let's also put a jumper cable between the two CanBUS ports. So CAN uses two pins, CAN high and CAN low. So we'll go CAN low to CAN low and CAN high to CAN high. If we were doing long distance or field communication, we'd also want to connect to ground together between each device. But for our short test here, it's not going to be necessary. Let's get started by logging into these devices. So we're going to call this device here device A and this one device B. So I'm logged into device A here right now. And let's go down to logic under examples. If we go to the very bottom here, you see there's a CanBUS example. Let's click on that. Let's Control A, select everything, Control C, copy it, and let's go ahead and paste that in here. And then let's go ahead and go through that line by line. So on the first line here, we initiate the CanBUS. So it's where we're setting up that port, initializing that port. So we select 125 kilobits per second baud rate. And right now we specify false for CanFD, which is CAN flexible data rate. And actually, let's change that to true for the purpose of our example. Auto retransmission allows you to automatically retransmit a frame if it's not acknowledged by the receive device. We're going to leave that false for our example, but it is something that can be useful if you've got noisy field communication, you don't want to lose data. On line 3, we use the can.listen function to set up a callback handler, which will be called anytime we receive data on the CanBUS port. And so this function here is going to be executed whenever we've received data or there's been any bus activity. And so in our case, we just print whatever that data was. We just print that to the console. In line 9, we set up a main loop. This loop is just going to repeat itself over and over and over again. And it's going to do that every second because we have a 1 second delay there. And on line 12, we call the CAN transmit function, can.tx. So let's send a message to ID 12. That'll be the destination ID. And this will be a payload. So let's say hello from A. Extended ID, CanFD, we are going to use CAN flexible data rates. Let's put true in there. Remote frame request, we're not doing that. And let's copy that and let's go ahead and put this on device B. And let's just say hello from B, and let's change this to 33. And so let's go ahead and test that. Test that. So now if we go down to here, we can see we're already receiving messages from device B. Hello from B, ID 33. And that was exactly what we'd sent over on this device. Hello from B, 33. And if we look at the log over here, we'll see hello from A, ID 12. And that was exactly what we had sent over on the side. Hello from A, ID 12. So let's go ahead and send something a little bit more useful here. Let's see if we can send the value of analog input 1 from device A to device B. So let's say create a new variable here, value equal inputs 1.instantaneous, and let's convert that to a string. So we use a toFixed function, 4 decimal places. And we could be sending this as like a binary value, like a floating point or signed integer. We're just going to send it as a string right now because that's the most straightforward approach. But if you were really trying to optimize that, you could send several integers as a binary. So send our value, and let's go see what channel 1 is. So let's go ahead and test that. If we look at device B now, we can see we're getting 0.0017. So if we connect, we have a battery here with a connector on it. So if we connect that into port 1, .6424. So if we look over here, we're now receiving that correct data. So if we want to show that on the screen here, or on the device screen, we could set up what we call custom feed. And this allows you to create a value that's been computed from logic. So maybe it could be your site runtime, it could be a battery capacity, percentage, anything that you'd want to calculate that may be based on the analog input values, but you want to do some math or logic on it. So that's what custom feeds are for. So we can create a custom feed here. Let's call it remote value. And notice its ID is 0. So on this side here, we could do that value equals number. So we're going to convert that string back into a number. Data.payload. And we're going to set feed 0 with our value that we received. And now if we execute that, then we can go down here to remote value, and we can also view that through the web interface here. So we could actually graph that off here. Remote value. Now if we unplug our battery, you can see it drops down to 0. It comes back up. So we just demonstrated sending a value over CanBUS, and this could be used to connect in with a battery management system. It could be used to read sensors from an existing automotive installation, or there's a lot of CanBUS sensors that are out there. Whatever the type of sensor, you can read it, you can support it. We've tried to make this as easy and streamlined as possible, and yeah, it should just give you a good framework to get up and running. You can do pretty much any conceivable CanBUS configuration with the Flexs Q5, and so it should be a good fit for whatever you might need. If you have any questions, if you need support, please feel free to contact us on our website, flexscada.com, and under the contact section. Thanks again for watching.